I am Mr. Auerbach, and it's Friday afternoon at 4:40, but here I am, and I'm going to make a video for you walking through a couple of these mole problems just so I can give a little help to people that are still trying to catch up with the concept, okay? So as you can see here on the screen, I have our first problem about the moles of silver. And so the first thing that you're going to want to do is go to the periodic table and find silver, right? Because if you're going to work with grams and moles of silver, right, that's the deal. How many moles are in 4.55 grams of silver? And so you need to know with these mass problems how much a mole weighs, right? If it says mass, then you're going to be looking for the molar mass. That's one of the things we have to learn. Whereas if we're talking about how many molecules or how many atoms, then you're going to be looking to use Avogadro's number. We'll do one of those also, but let's look for silver right now because we need to know the molar mass, the mass of 1 mole of silver. And here it is. Silver is Ag for argentum. I don't know why. And it is 107.87 grams per mole. And so we'll go back and actually I'm going to go to a screen that I have queued up here to show you a little whiteboard that I've got with the problem set up, okay? So we got 4.55 grams. Oops, I didn't mean for that to be crossed out yet. There we go, 4.55 grams of silver. And we see that we've got two conversion factors here. 1 mole of silver over 107.9 grams and 107.9 grams of silver over 1 mole. And those are going to work. The one that you decide to use will depend on what you're trying to do. And you can see here that I'm starting with a mass of silver, and I want to end up with a number of moles, right? Oops, moles is under here, hold on. A number of moles, right? And so I will set this up so that the conversion factor I pick, which by the way will be this one, will have the molar mass of silver on the bottom, because really what we're doing is dividing our given amount by the number of grams in 1 mole and seeing how many moles that is. And so this conversion factor is just a way to help us set it up so that we're doing the right operation, dividing when we should divide, multiplying when we should multiply. And so I'm going to put the conversion factor here, which is this one that says 1 mole Ag, 1 mole of silver, over 107.9 grams. And that is going to set us up. What that turns into, let me draw a nice red line here so that we don't mix all these parts of the problem up. So, in fact, I'll do this next part in red. What this turns into is one big fraction, right? For those of you really struggling with the math concept here, 4.55 grams silver times 1 mole silver all over 107.9 grams, right? That's what we got here. Whoops, I don't know how that got on there. So that's the long fraction we get once we combine these two expressions. And then what we get to do is we cancel out the like terms, which in this case is going to be, oops, that should say grams of silver. Grams of silver and grams of silver are both in this fraction, which means that over each other they equal 1. And so we can eliminate them, and that just leaves us with what we want, which is moles of silver here. And so that's great. So then we can re-simplify this to tell us the operation we're doing, 4.55 moles Ag divided by 107.9. Nothings, right? Because the silver grams have been removed. So then we just do our operation, and I'll bring up the calculator here. And let me move it over so you can see it. Whoa, what just happened there? I don't know. Okay, 4.55 divided by 107.9, right? And that tells us 0.042. And so let's go ahead and minimize the calculator, and we'll write that 0.042 moles, right? Let's bring this over. Moles of Ag, silver. And then we want to ask ourselves, does that make sense? And I would just remind you that, we have way less than 1 mole, right? 4.5 grams is way less than 107.9 grams. And so this number, 0.042, really is about 4.2%, if you want to think about it, of a mole, right? If we were to think of this as a percentage, it would be 4.2%. So we ask ourselves, is this number 4.2% of that number? Seems pretty close to me. Anyway, so there is 1, and I am going to pause here for a second, if I can figure out how to do that. Maybe I can't. I think I'm going to have to just make another one for the next problem. So we'll do that. So, actually, you know what? Never mind. I'm going to erase real quick, and we will move on to another problem where we're going the other way. Where we are going from, instead of mass to number of moles, this time we'll go from moles to mass. And that's moles, sorry. Let's look back at the worksheet and see a problem that's from moles to mass. Okay, so how about this one? How many grams are in 4 moles of zinc? Okay, so this is the opposite, right? Instead of going from grams to moles, we're going from moles to grams. And let me write this out. Well, first, let's stop at the periodic table and find out how much 1 mole of zinc weighs, right? The molar mass of zinc, which is Zn. Here it is. It is 65.38 grams for 1 mole. And so let's go back to our whiteboard, and we will do our 4.0 moles of zinc. And our conversion factor is either going to be 1 mole Zn over our, what is it, 60, I'm going to say 68.35 because that's what I remember. That might be wrong. 68.35 grams, or 68.35 grams over 1 mole. Well, which one are we going to use? Well, let's think of it this way. When we multiply our 4 moles of zinc times our conversion factor, we're going to want the thing on top that is going to replace moles. In other words, grams. So we're going to want our answer in grams, right? 4 moles of zinc is how many grams? And so which one of those has grams on top? It's this one here, 68.35 grams, which I think is the molar mass as I remember it, of zinc over 1 mole zinc. And that turns this into, let's neaten this up a little bit. That turns this into a combined fraction of 4.0 moles zinc times 68.35 grams. All, oops, sorry, big fraction, so sorry, sloppy, all over 1 mole of zinc. Okay, so, sorry about this, we're getting all sloppy here. Friday afternoon, I'm sorry. Anyway, so as you can see, we have moles of zinc over moles of zinc here, and so that turns that into 1. Anything over itself is 1, so I can cancel those out. And so all we're left with is 1 underneath, which we can also ignore, right? Anything divided by 1 is just itself. And so really, we have 4 times 68.35 grams, which makes sense. Every 1 mole is 68.35 grams. We have 4, so we should multiply 4 times the number of moles that we have. Okay, just like if I said you have 4 dozen eggs, you would multiply, well, let's not talk about eggs right now. Let's just do 4 times 68.35 on our calculator. 4 times 8.35 gives us 273.4 what? Grams. That should not be crossed out like that. It was an accident. And so that answer is, what was it? 273.4. Grams, right? We ask ourselves, let's not get the decimal point there. Ask ourselves, does that answer make sense? Yeah. Every, a mole's almost 70, 4 times that, almost 280. If I remember my multiplication tables correctly, that answer seems to make pretty good sense. Okay, so there is 1 mass to mole problem and 1 mole to mass problem. That should take care of about half of this assignment, and I will make another video that does the representative particles side of things, your atoms, molecules, etc. Until then, have a great day, and I will see you next week. Goodbye.